the light to the study of chemistry was brought about by the discovery or the theory propounded by John Dalton in 1808, John Dalton of England in 1808. So this theory gave light to chemists. It brought light to the study of chemistry, even though there were postulations to the existence of theories, existence of atoms by Greek philosophers. But the theory put forward by John Dalton in 1808, John Dalton of England in 1808, brought the light to the study of chemistry, via which modifications and other principles and laws and everything was built. All right. Now, in John Dalton put forward his theory. There are 5 theories. The first is all elements are made up of small indivisible particles called atoms. So, in this first theory here, he says that all elements are made up of small indivisible particles called atoms. That is to say, there are atoms which constitute an element is indivisible. It can't be broken, it's unbreakable. So it can be splitted. The idea as representative, as constituents of elements, unbreakable. So that, according to him, that's what he said. Secondly, he said atoms cannot be created or destroyed. It can't be created or destroyed, but can be converted from one form to another. That is the full statement of that theory. The atoms cannot be created nor destroyed. That is what he said in the second theory. Alright, thirdly, he said atoms of the same element are alike in every aspect and differs from others. Atoms of the same element are alike and differs from others. Atoms of different elements can combine in simple whole number ratios to form compounds. In simple whole number ratios. Let's say, for instance, this is 2:1, 1:2, 2:3. So these are simple whole number ratios, or 1:1. These are simple whole number ratios. So according to John Dalton, atoms of different elements can combine in these simple whole number ratios to form a compound. Well, these are his statements. There are 5 actually, but let's consider these 4. Now, these are his statements, the statement in his story. But the question is, how generally acceptable are these statements? Now, we'll look at this now in the modification of John Dalton's theory. So, as you see, as time evolves, scientists, chemists started noticing that there are limitations to the theory compiled by John Dalton. Even though this theory compiled by John Dalton has limitations, they are not totally discarded. Till today, the theories are still usable. They are still being used in the study of chemistry, even looking at the light that the theory has brought to chemistry. As we go on, let us now look at the modifications of this John Dalton's atomic theory. The modifications will now tell us or reveal to us the limitations in these theories that John Dalton has said. Alright, now the modification of Dalton's atomic theory, that is the modern atomic theory. So the modern atomic theory came to modify or to correct the limitations in Dalton's atomic theory. Now let's take it gradually, one after another. The first theory by John Dalton says all elements are made up of small indivisible particles called atoms. Now this was his first theory, but as time evolved, during the study of scientific study of Ernest Rutherford discovered that the nucleus of atoms composes of small particles like the neutrons, the protons, and the electrons. Now looking at that, that is to say the nucleus of atoms. This is the nucleus of atoms. Here is the nucleus, and in the nucleus here are composed of the proton and the neutron. So this is the nucleus. In the nucleus are the proton and the neutron, which combine to form the nucleus of the atom, the mass of the nucleus. So, and also in the outermost shell of the nucleus here are electrons revolving around the nucleus. That is to say that the nucleus of an element contains three other smaller particles, which are what? The proton, the neutron, and the electrons. Protons, and electrons. So in this case now, this theory, all elements are made up of small indivisible particles called atoms, does not totally hold anymore. Why? Because of the discovery of other smaller particles. Alright, now let's take a look at the second statement by John Dalton. Alright, the second statement, he said atoms can not be created or destroyed. John Dalton says that atoms cannot be created or destroyed. But the question is this totally true? Well, in this case now, this is only possible when we are discussing the inorganic chemistry. And so it is simple chemical reactions. But when we go into radioactivity, the discovery of radioactivity countered this theory. Now, when elements that are in chemical radioactivity are being bombarded, when the nucleus of an a radioactive element is bombarded, it is destroyed, forming other simpler other elements, other substances. Let's take for instance when the nucleus of uranium is decayed. When the nucleus of uranium is decayed by alpha particles, it forms thorium and alpha particle with the release of a larger energy or heat. Let's take an example to this. This is 4. This is 2. So in this case now you see that with the discovery of radioactivity or chemistry of radioactivity, this law, this theory, atoms cannot be created or destroyed, no longer holds, but it only holds in simple chemical reactions. I believe this is understood. So let's go to the third statement. Alright, the third law, the third theory, he says the atoms of the same elements are alike in every aspect and differs from the atoms of other elements. This is John Dalton's third theory. Now, this is also limited. This also has a limitation when isotope is discovered. The discovery of isotopy renders this theory totally not accepted. So in this case now, when we look at chlorine, chlorine has 2 isotopes of chlorine. We have 2 isotopes of chlorine, chlorine 37 and chlorine 35. You see, the same thing applicable. Oxygen too has, I think oxygen has 3 isotopes and other elements. So the discovery of isotope now renders this theory not totally acceptable. So now let's take a look at his fourth. In the fourth theory, he says that atoms of different elements combine in simple whole number ratios to form a compound. Simple whole number ratios to form a compound. So now this also has its own limitation when organic chemistry was discovered. So this only holds in inorganic chemistry. In inorganic chemistry now, elements of different atoms of different elements combine to form a simple whole number ratios. Like simple whole number ratios like 2:1, 1:2, 3:2. So these are simple whole number ratios. They are whole numbers without decimals attached to it, without fractions. So in the case of organic chemistry, carbon forms large weights of compounds such as the fats, protein, starch, and all those. Very large. That is where we start discussing catenation. And in this forming of these compounds now, they are not formed in whole numbers. So in this case now, we'll be seeing something like 3.42 is to 2. So this is not a whole number. Only this is a whole number. Sometimes you have 5.14 is to 2 when trying to find the whole numbers in which the two atoms are being combined, or the two elements are combined to form a compound. So in the case of organic chemistry now, this statement here is not totally true. So when we start discussing empirical and molecular formula, we'll come to, maybe in our next video, we will come to see something like this, and we'll disapprove this statement. So the limitation, what is the limitation to this theory? Atoms of different elements combined in simple whole number ratios to form a compound, the discovery of organic chemistry. So that is catenation of carbon, and also sulfur to renders this law limited. So these are the modifications of atomic theory. I believe this is well understood to this point. I'm going to display on the screen here those. I'm going to display on the screen the modifications of this law. The first will carry the theory by John Dalton, and then below it you see the modification of that particular law. I'm going to place it on the screen for you so that you will understand it very well. This is just explanations of those everything treated. However, if there's any difficulty or you have any questions to ask, please drop it in the comment box. I will be right there to attend to it. Thank you very much for watching. See you next.